Generally, when we ask what is a tangent, the common answer that we get to hear is tangent is a straight line that touches the curve at a single point. So let me consider an example here. So we have a curve, and at the point P, I try to draw a straight line that touches the curve exactly at a point. And we know that this is not a tangent, but still it satisfies the above definition. Let me take one more example. So this curve is a straight line, and I try to draw a straight line that touches the curve at the point P. And this straight line which I have drawn is actually a tangent, but it does not satisfy the above definition because this straight line does not touch the curve at a single point. It in fact touches at more than one. So what could be the better definition for tangent? So a tangent to a curve at the point P is a straight line that approximates the curve at least in a small open interval containing the point P. Let me explain to you this definition with few examples. We consider a curve and I draw a straight line that touches the curve at the point P. And here we see that there is a small open interval containing the point P in which the straight line and the curve are approximately equal. Any other lines that we try to draw at the point P will not approximate the curve, therefore they cannot be the tangents. Here we take one more example, and I try to draw a straight line that touches the curve at the point P. Here we find that there is a small interval in which the straight line and the curve are approximately equal. Therefore, this straight line is a tangent to the curve. Let's move to the third example. Here, the curve has a sharp edge, and I try to draw a straight line that touches the curve at the point P. Can we find out a small interval? It could be however small, in which the straight line and the curve are equal. No, we don't find. In fact, you try to draw any way you want, any number of lines. They will not actually approximate the curve in however small interval. So, I usually like to put the definition of tangent in this way. A tangent is actually a linearization of a nonlinear function, at least in a small open interval containing the point P. So, linearization means we try to make a nonlinear curve, a bent curve, straight, at least in a small interval. So that's the meaning of this definition. Here we come to a very different way of understanding the tangent. So here the tangent has been defined as the limit of the secant line joining the point A and P, where A is approaching closer and closer to P. Let me explain to you this definition. Here I consider a curve, and here is a secant line. The definition says as A is approaching closer and closer to P, the secant line tends to be a tangent. Let me check that. I try to move the point A closer and closer to P, so I get different lines here. So finally, as A approaches very close to P, what we get is actually a tangent. In fact, you see here, this straight line approximates the curve in a small open interval containing the point P. In this definition, as A approaches closer and closer to P, whether it is from the left hand side or from the right hand side, we must get the same line. If we were to get two different lines, in that case, those two lines cannot be called as tangents. The famous mathematician Leibniz defined a tangent as tangent is a straight line through a pair of infinitely close points on the curve. Let me summarize what I said so far. First point is tangent must approximate the curve at least in a small open interval. The second point is at a given point, if tangent exists, it must always be unique. And the third point is tangent does not exist at a sharp edge of a curve. So that's all for now, students. Let's meet in the next video. Until then, take care.